Okay, we're solving quadratic equations, this time by completing the square. This is the third of four different ways to solve quadratic equations. We've done factoring, we've done taking square roots. This is completing the square. There's one more, the quadratic formula. We'll get to that soon. But first, I've got a question to ask that I need to make sure you understand, and that is, what is a perfect square trinomial? Well, you probably know what a perfect square is. 16 is a perfect square because you could square 4 and get there. 36 is a perfect square because you could square 6 and get there. 144 is a perfect square because you could square 12 and get there. Well, a perfect square trinomial is a trinomial that you can get there by squaring. Let's take a look at some examples. Okay, I'm going to square x plus 7. That would be x plus 7 times x plus 7. And then we're going to multiply that out. As you probably remember from multiplying binomials, you can do this by what we call FOIL. Multiply the first pair, that's x squared. Multiply the outside pair, that's 7x, and the inside pair, that's also 7x. So you got 14x, okay? And then multiply the last pair, you get 49, okay? Here's another one. X minus 5 squared would be x minus 5 times x minus 5. Multiply the first pair, you get x squared. Multiply the outside pair, you get negative 5x. Multiply the inside pair, you also get negative 5x, so that's negative 10x. And then multiply the last pair, you get plus 25. Well, I want you to look at something I noticed here. Okay? When I squared this thing, I got x squared. I got two 7x's, and then I got the square of that. Here I got x squared, okay? I got two negative 5x's, and I got negative 5 squared, which is positive 25. So I'm thinking I could do this in my head maybe. If I had x minus 9, okay, I could multiply that and say, well, I know I'm going to get x squared. I'm going to get minus 9x, because that's negative 9 times x, and another negative 9x, so that's negative 18x, and then negative 9 squared is positive 81. Okay, well, I've gone from a squared binomial to a perfect square trinomial. What we're going to do is go the opposite direction now. So if I have x squared plus, let's say we've got 8x plus 16. Let's see if it works. Well, I knew these worked, and here's the cool trick I knew. If I had two 7x's, I'd get 14. Okay, so two 7's would get me 14, and 7 squared gets me 49. If I had two negative 5's, I'd get negative 10, and negative 5 squared would get me 81. So here's the basic idea. If I can take half of this and square it and get that, then I'm good to go. Okay, so down here, half of 8 is 4, squared gets me 16. I'm good to go. Now what do I get? Well, I'm going to get something squared. I'm going to have an x here, and then I noticed on all of these, the number I had here was half of that number. So negative 5 is half of negative 10. Negative 9 is half of negative 18. So what's half of positive 8? Positive 4. Okay, let's do another one. X squared. Let's see here. I'll get a good one for you. Minus 16x plus 64. Let's see if it works. What's half of negative 8? What's half of negative 16? Negative 8. When I square negative 8, do I get 64? Yeah, it works. Okay, so I can write it as a perfect square, as a squared binomial. I'm going to have an x, and then half of this number is right there. Well, now we're going to use that. Okay, here's a quadratic equation, and I noticed this thing fits. This works. Half of 10 is 5, and 5 squared is 25. So I could write this as x plus 5 squared. Okay, just like I did before. I had a squared binomial, and then this number was simply half of that one. if it works. Okay. Now we still have a plus 30 or equals 36 over here, but now I'm down to a kind of equation I've used before. I've done taking square roots to get solutions. So I'm going to unsquare x plus 5 squared, and I'm going to get x plus 5. So I square rooted this side. I'll square root this side and get 6. Don't forget I have plus and minus 6. And then I'll subtract 5 from each side. Okay, now I can keep going here because positive 6 minus 5 is 1. Negative 6 minus 5 is negative 11. There are my solutions. Okay, so I use this writing this thing as a squared binomial. We call it completing the square, and you'll see why we call it completing in just a second. I made the thing a perfect square trinomial, and then I dropped it down to a squared binomial, and then I could solve that. So let's look at another one here. Okay, let's check and see if it works. Is half of 10 squared equal to this number? No. Okay, that didn't work. Okay, so here's what I'm going to do. I'm first going to get rid of this number by just adding it to both sides, just to get it out of the way. So I have x squared plus 10x, and then equals 16. And I purposely left myself some room here, and you'll see why in just a second. Okay, now, what did I really want to have here? Okay, I really wanted the 25 because half of 10 squared is 25. So here's what I'm going to do. Since I wanted the 25 there, I'm going to put 1 there. Okay, now you won't let me get away with adding 25 to this side without also adding it to this side. So 16 plus 25 is 41. Okay, now it's set up so I can solve it. I'm going to write this as a as a squared binomial, just like I did before. I still have a 41 here, and now I can solve this exactly like I used to. Square root both sides. 41 doesn't square nicely, so I'll just leave it in a square root sign there. Don't forget your plus or minus, and then subtract 5 from each side. Minus 5, minus 5, and so here's my answer. Oops. X, and this thing doesn't clean up very nicely, so honestly I'm just going to leave it alone and call it my answer. Okay, plus or minus square root 41 minus 5. If you want both answers as decimals, no problem. Find the positive square root of 41 and subtract 5 from it, and find the negative square root of 41 and subtract 5 from it. Okay, let's look at another one. Okay, does this one work? No, because half of 8 squared isn't 12. So some people just say, look, I wanted 16 here, so I'm going to add 4 to both sides. Other people say subtract 12 from each side to get x squared minus 8x equals 3, and then figure out what you need to add there and add it to both sides. Okay, if it were me, I like to joke that I didn't learn math because I'm smart. I learned it because I'm lazy. Adding 4 would have gotten me done faster, but I'm going to do this just so that you've seen this. And some software products expect you to do that, or they show their work that way. Okay? So now I'm going to ask again, what did I really want right here? Well, half of negative 8 is negative 4. Negative 4 squared is 16, so I really wanted the 16 there. So I'm going to put a 16 there. And of course I'll add 16 to this side, so I get 19. Now I can continue on the way I was doing this before. I'm going to write it as a squared binomial. X, half of negative 8 is negative 4, and 19. I'm on my way. I can square root both sides. 19 doesn't square root nicely, so I'll just leave it under a square root sign and call it good. I won't forget my plus or minus, and then I'll add 4 to each side, so I'll have negative or square root 19 plus or minus, and then plus 4 because I'm adding 4 to both sides. Okay. If somebody wants you to write 4 plus or minus square root 19, no problem, they can do that. Okay. So one more. Oh boy, this looks pretty ugly because it's got a 3 there now. Okay, so here's what I'll do. I'm going to get rid of the 5 first. So I'll write 3x squared plus 30x equals 5. So I just added it to both sides. Now, this is the first time I've had a 3 out in front there, so you know what I'm going to do? I'm going to divide everything by 3. Okay? I'll divide this by 3, this by 3, and this by 3. So that's going to get me x squared, 10x, and 5/3. Okay? I'm not going to bother with 1 2/3 or decimals. I'll just leave it as a fraction. Okay? Now I'm going to ask myself, what do I really want here? Well, half of 10 is 5. Square that. I want a 25 here, so I'll add 25 to both sides. Okay? That's not pretty, but it's doable, right? Okay? I could have written that as 5/3 plus 75/3. Okay? They taught me how to add whole numbers and fractions. I just made the whole number into a decimal, 25 over 1, gave it a common denominator. Great, I got 80 over 3. Okay, so now I can do exactly what I did before. Write this as x plus 5 squared equals 80 over 3. Okay, square root both sides. X plus 5 is plus or minus square root 80 over 3. Okay. If your teacher expects you to rationalize the denominator, you can watch a video on how to do that. I'm just going to leave it as plus or minus 80 over 3 for right now. And then I'll subtract 5 from both sides. And I'm almost out of room, so I'm just going to subtract 5 from here and put minus 5 right there. And there's my answer. Okay? So if there's a number out in front, it gets uglier. Okay? So I want to show you that here. This thing, oh my gosh, that looks terrible because 4 is not even going to divide into 15. So you would start out this way. You'd write that there. Then you divide everything by 4. You'd have x squared plus 15 fourths x equals negative 7 fourths. Okay? Then you'd have to figure out, what do I need to add right here, actually on both sides. Okay? Well, to do that, you'd have to take half of 15 fourths and square it. Okay, let me say it again. You'd have to take half of 15 fourths and square it. Well, half of 15 fourths is 15 eighths, and then square that, and you get 225 64ths. Okay? Oh my gosh. So you'd end up with x squared plus 15 fourths x plus 225 64ths. And don't forget to add 225 64ths to the other side. Okay? Now, you'll need to end up combining these two fractions together, so you'll have to get a common denominator, which means you'll have to multiply the top and the bottom by 16 to make this thing have a denominator of 64. Okay? Once you get that answer, you will say, okay, x plus something squared equals whatever this is, okay, and then you'll have to figure out what half of 15 fourths is, which was 15 eighths, okay, plus this mess down here. Now, why am I stopping? Okay, this is getting ugly. I mean, you can do it, and if you're watching how to develop the quadratic formula, you'll see this, but it gets to the point here where you're going, you know what, there's got to be a better method, and there is. It's called the quadratic formula. Now, the quadratic formula will come from these skills, but I'm going to stop here because we're kind of past what we really need to be doing. If I get a problem that looks like this, where this number is not divisible by that, then I stop and say, look, I've got a better way to do this. Back on my list of methods here, I've got the quadratic formula. That thing will take care of that. I don't want to use the completing the square method for something really ugly like that. So that's completing the square. Again, to do that, you need to be able to have the skill of being able to go from a perfect square trinomial back to a squared binomial. Once you can do that, then you'll take the perfect square trinomial, factor it down to a squared binomial, and then you'll solve it just like we did back when we were solving quadratics by taking square roots. Okay, that's going to do it.